Well, is anybody out there? We're going to do a video on laying out a solar array. I still want a wind turbine, but we're going to investigate this and see what it costs. And the little thing that's going to make it workable is these. This is a U-bolt. Tell the size. It's 3.5-inch pipe. $1.97 from Granger. Comes with 4 nuts. And we're going to get to where we use a whole bunch of these. Okay, the first thing we need to know is the latitude of the site, and it's in decibel is 14.75 degrees. So we want to tilt our panels at 14.75. Next thing to decide is what time in the morning and what time in the afternoon do you want sun to hit the panels. So you have to clear obstructions that would block sun. Now, this was a circle divided into 24 segments, 24 hours. Where's my pointer? This is 7 o'clock, 8, 9, 10, 11, 12 noon is straight up. I marked the hours on them. And I decided around 7:30 would give enough light to make it worth doing. So that's about in here. Now this array is turned 90 degrees. And I don't know how to explain it. Now, what I'm looking for is that when the sun is coming basically from the end at that angle, this little stick figure here would be turned 90 degrees. So it's at 7:30, it's intersecting about a 10-to-1 slope here, so only 10% output. And if the panels are really, really clean, then it's going to reflect a bunch of that off. So it's not even going to get to 10% of the intercepted area, probably like 8. So anyway, we had to have some idea what angle to put them and what 7:30 look like and 8 o'clock look like. It's kind of looking like the 10 o'clock, 10, 11, 12, 1, 2, maybe 2 or 30 is a time of day we can collect something off of it. Step 2. I looked up various manufacturers of solar panels and got the specifics. This is the that's the brand name. This is a 40.5 volt, 330 watt, and the dimensions are 66.3 by 39.45 by 1.38. Now these are the if you consider this just a block of material, that's the size of things you're going to nest together to make an array. And so the most we would probably be looking to do is 7.3 kilowatts. And that's 24 panels. Now, having that size, I went on and looked up a bunch of more brands. This is a Panasonic. It's partnered with Tesla. They took over a little desert, couple houses on a road called Sparks, Nevada. I think they renamed it, actually. Anyway, theirs is 58 volt. It's got 96 cells. I got the cell count for most of them on these things, and this is the dimensions. These are in inches. I don't know why they rate them. Every one of them was, I think, rated in inches. And this one, instead of being 1.38 thick, is 1.57. That's just how they broke the piece of metal that it's mounted to, because the things are hollow, you know. Let's go down. I'm not sure which one I used to set this thing up, but it was the longest one. This is 72 cells and 47.8 volts. Oh well, it's too late now. I must have typed that and then tried to add the word volt as a separate text element, and I got it in the wrong place. Anyway, you get the gist of it. We got a whole bunch of different manufacturers and the sizes of the cells, and then we lined them up with the center point of each panel in line. This line down the middle is the middle of every one of them, and what that allows is to draw lines where the panels join. Let's just take a look at one of them. Now, these red lines are close to where the panels join together, but not necessarily on them. They're just close. And that's because we have to have supports for the pipes that these things are going to be bolted to. I need a place to put them that's not at the 1 foot mark from the end of the panel. So we're basically going to have to come up with a scheme where these proposed locations don't interfere with the mounting points, which we've just selected to be 1 foot from each end. We're only going to use 4 points of mount, and on the long side reels, we're going to mount them horizontal. So once we come up with this perspective places, then we went a little on to see what we could do with that. Let's go to the next little thingy here. Okay. So this is our 14.75 degrees. Now, that's good for autumnal equinox and, okay, let's put it this way. You have summer solstice and winter solstice. That angle is like half the degrees that the Earth is rotated. So the sun's going to be coming from some direction all year long between those two lines, with vernal equinox and autumnal equinox straight down perpendicular onto it in the middle, splitting those two lines. Now, the next thing here is problems with our site. They've set our place on fire 5 times so far since 2014, and some smaller fires in between, and one we had on our own because I couldn't stop people from burning stuff on a windy day. In any event, I decided to put concrete walls in front and back of this thing, and 4 sides. It does 2 things. My primary concern with not doing solar in the first place was I didn't think I could mount the things out there and have typhoons blow through here. We're out in a big exposed area, out away from things, out in the provinces. We're not in a city lot. You know, we haven't got all the buildings around us. This is a wide open space. So we have to contend with typhoons, and the typhoons come from this, where the tall wall side is. And that's just lucky to draw. Where we are and where China is and things like that. We can't change those. But it's going to be coming this way. So I wanted a wall that was 2 feet higher than the panels. And I can put a little sheet metal deflector up here and trip that boundary layer to where this is just turbulence. It won't have any real linear flow to it. The height off the ground was chosen to make it where you get under and do wiring and stuff when you're an old person. When you get 80 years old, you don't want to try to get up and down off your hands and knees a whole lot. A roll-around chair on wheels and standing up for the rest of them seems like a real nice thing. So we come up with basically how big the enclosure had to be. And also figured this, knowing that angle that the sun is at 7 o'clock, we know how high we can make this this edge wall here. So that edge wall there at the 2 feet is what determined the height of these two walls. Now this is a preliminary sketch. This is the first hit at it. Our slip forms pour 4 feet. I could go up till I hit this line here on the height of the walls. So this wall will be taller. It'll be at least 4 feet. It's easy to pour a whole height of a slip form. These are the numbers in inches of the inside of the box, the inside of the walls. And this is just for measuring the drawing. There wasn't anything more to it than that. The drawing was sort of subjective to what I thought I wanted to do, and I just measured it. So there's no real rocket science there. We're going to look at something out of order here, only because I have to change the scale on the dimensions to be able to read the dimensions on the wrist. Okay, this is the bottom bracket. There's that U-bolt we showed. The red line is a 3-inch pipe, which is 3.5 inches OD. So the U-bolt is onto a plate. That's the one here on the right. 5.5 inches square, fit for the U-bolt. And in the middle, we have a 3/4 inch nut welded to the bottom of the plate. Welded around the bottom. And we have an 1.5 inch bolt. Now, I've investigated muffler clamps, saddle clamps, pipe supports, hanging pipes, brackets. The minimum buy-in for a muffler clamp with a saddle was $7.97. And the ones for pipe supports like you'd use for sprinkler system, they were $37 each. These are $1.97. And I have to mount them to something anyway, so I just made it to mount a U-bolt. It just gave me a dimension I had to work from. And the 5.5 inches is because I wanted to use a 1/4x8 flat bar just to shear these things in my machine shop. Now, and this is the plate that you see on the right here. And it'll have 4 pieces of 3/4 threaded rod. The 3/4 threaded rod gets a nut underneath of this plate, so it's a steel surface it's attached to. Nut on top to hold it all down. Then it goes down into concrete a foot. And the bottom of that foot, you have a little square plate about 2.5 or 3 inches, and a nut welded on the bottom. And that keeps it from turning. The threaded rod between the bottom nut and the top nut, which is going to be flush with the concrete, gets a piece of plastic pipe. If you ever have a problem bung up the threads up here, or somehow you break this 3/4 inch threaded rod, I don't know how you'd go about doing it. I have to have at least 2, hopefully on opposite sides, but I'm going to put in 4. Anyway, you can unscrew that threaded rod out of that bottom nut because it's enclosed in a piece of blue PVC pipe. The concrete doesn't touch it, and it's flush with a nut at the bottom, or it can run past it 1 inch and you wrap it with electrical tape. I've done this in industrial foundations, except we use a much bigger pipe. That if that was a 3/4 threaded rod for a machine anchor, we'd probably have it in a piece of 1.25 inch pipe. And that way, if you're a little off on any dimensions, you can wiggle that machine around and the bolts are still sticking out through where they're supposed to bolt down. Anyway, this is my scheme for the bottom mount to hold the pipe onto a concrete column. Concrete because we're in the Philippines and the termites are rampant. You also see another one that looks like this same plate. Probably, it actually is the same plate, but this is turned upside down and rotated 14.75 degrees. This bolt does 2 things. It takes the place of the saddle under the pipe, and it gives you a height adjustment because the bolt can go up and down with the bottom of the pipe, and the U-bolt can be threaded in or out. Nuts can be threaded on or off here, and that lets you tweak this if the concrete's not perfect, because you don't really want to bend all this stuff. So you can just use a laser transit and get it skimming the top of the bolt or the plate, whatever you want to set it off of. but then you have to have something from the pipe to go up and mount the solar panels. So that's the next deal here. That's the same bracket, but oh, I forgot. What you see here, this rectangle, that's a piece of offcut of 3-inch pipe. And it's 1.320 long. That keeps that nut and the bolt down in there, and also gives you wrench access over here to these 1.8" headed nuts for a 3/4 inch threaded rod. Okay, the one that's rotated up here 14 3/4 degrees. There's 2 U-bolts, and they are outboard of a 1.5" by 3 piece of tubing. This a rectangular galvanized tubing is going to run across here. And I don't think I'm going to have this adjustment bolt here, because that would be underneath of the tubing. So this was a preliminary design when I was using the adjuster bolts, and I just grabbed this piece here in the drawing from there and flipped it over. So it doesn't really have that bolt. It's it's in there, but the drawings aren't complete yet. They're just you have to know what you're going to build before you can do a cost analysis on it. Okay. First one is the one with the jack bolt in the middle. And it's 5.5 inches square. And obviously it's 3.5 inches between the centers on these bolts to fit the U-bolt. Second one is the one for the top, which hasn't got the center hole. Other dimensions are the same, but so you can have a separate drawing. It's less confusing for the guy that's making them. No, we just have a separate drawing with the hole left off. This is our 8 by 8 inch plate. And, the reason that the bolts is in the center rather than the traditional corners is I'm working with concrete. I'm not working with steel in this case. And a bolt right in the middle, you've only got the cover on these 2 sides, and you don't want to blow that out, because these bolts are outside of the stirrups of the rebar cage for the column. You're going to have 3, and 1 on either side. That's 8 vertical rebars. They're a fairly small diameter because it's an 8-inch column, so they're the 12s or 10s. I haven't figured that out yet. But this way I can have this thing go down and like one point towards the other. It'll be like around in a square, and just grab the whole column of steel. This little cutie might take some explanation. You've got 2 plates here, and those will go on the 1.5" by 3 rectangular tubing. It'll be going through this rectangle here, endwise through it. Up here is where the solar panel will be, between the purple and the red. But looking at them, they look at it from the side, because one panel plugs in from here, one panel plugs in from there, and this is a 3/4 inch grip onto the edge of the panel. Some of these panels have a fairly narrow frame, and you'd be covering up, or worse yet, clamping down on a silicon material, the monolithic silicon. So I kept that at 3/4 of an inch. It would be an awful bow in that panel for it to come flying out of there in a storm. And if it did, it's probably destroyed by then. This 3/8 by 6-inch bolts, galvanized. The top cap is above the solar panels, so it needs to be 3/16 stainless or aluminum, like 6061 be good. We're just doing this because the dimensions, I'm going to change the scale so the dimensions are readable in the other drawings. I know this is out of sequence, but hey, I'm old. Do anything when you're my age. People have too much respect to call you on it, I think. This is the little red top cap. You'll notice it's got a hole smaller than 375. No, it doesn't, but it should. This is the bottom one. This is the one that the bolts run through. This sandwiches the 3x3, 2.5 by 3 galvanized tubing. Yeah, okay. This is 2,000 smaller than the bolt for a press fit. The reason for the press fit is if you watch people installing solar panels, they're forever trying to tighten a bolt out of their reach, out on the middle of that field. They have to hold both ends of the bolt. So I decided with them in this rectangular piece, if I press fit them into this purple piece, then it holds itself. And all I have to do is turn the bottom one from underneath, and you can walk right up to that because you're not climbing on your panels. So the idea here is a press fit 2 bolts down through there. Even though they're press fit, every nut and every bolt head gets the external tooth, what do you call them? Serrated tooth lock washer. Externals have a lot more torque capacity than internal, but the internal looks nicer. Anyway, those need to be either stainless or zinc plated or something. Again, you don't want any rust stains run down across the panels. That's all the players. So let's see what we can do about making the dimensions readable. There's dimension. Can anybody read that? I can't. So file, properties, dimensions. I don't know. I guess that's all right. And you can see here, there's the things we just looked at. And when I made dimensions that big, you see how it obliterates the drawing. I could turn this into a block instance, but then I can't modify it. But I could turn it into a block instance, and then it wouldn't change. I could have different dimension scales on the different things. That's just one of the lovely parts of CAD. And this is showing you that the panel, if it was all the way down, would be 36 inches to the top. And that'd be 30 minus 1 3/8 for the thickness. That's where the wiring is. And if you turn them the right way, the wiring will be up here, which is even taller. And this gives the dimensions of the post from the walls, height of the walls. And again, this was the first run at it. So the center column, I put out of 3 columns instead of 2. The material will be strong enough to hold it. You could walk around on top of it. But the thing is, we're looking at typhoon resistance. I don't want it getting a rattling flutter, aerodynamic flutter, and just tear it all to pieces. Very powerful stuff, flutter. Makes airlines inoperable half the time. That's a little later step. I don't know why it's there. That's okay. This is the where the posts go. The pads for the posts are 24 inches square, and they're this kind of dimensions between the rows. The starting point of each pad, that would be these dimensions up here on the top. You notice that'll be the leading edge of each of these. There's one down here someplace. See this 24.9740? That's the width. And the 93.4487, that's the distance from the outside edge of the wall. The found is that the wall? No, that's the footer. That's the outside shape of the slab. You got a 8-inch deep by 24-inch wide thicker place under the slab. So the slab and the footer are all poured monolithically, one pour. But we have dimensions across here and dimensions up and down. And later we'll see this thing in a cross section. But that's the where the post would go. For any brand of panel I could find a dimension on. And once we got that, I have another drawing here with a bunch of numbers on it. Oh, this is a drawing showing where the mounting rails for the solar panels go. And once I had the mounting rails 1 foot in on the solar panels, I found out that a few of my posts were conflicted. Let's look at one little place here. Here's our post with our pipe mount and all that crap, and the spacer pipe showing there. Some of them, this up here was overlapping these, and when you can do something about it, why not? So what I did was I just put them. I moved it to two rows that conflicted to be centered on the between these, and I just basically shifted the whole group of posts that were working out to be centered between these. So that's like a major revision. We can't call it anything else. And these are the numbers for all this. Well, you know, this is looking at an angle. Makes the numbers distorted. Again, this is, oh no, this, okay. Lost my gizmo. Can't do it without my pointing finger. This, you'll notice, is all measured off the inside of the concrete surround, not the slab. Because you're going to be measuring this after the concrete is poured, and you can butt your tape up against that, but you can't do much about the edges of the footers and foundations, especially when you're 8 feet up in the air. But you have got a wall over here that's at the same height. So you can use one of those electronic tapes that goes to 2 decimal places. Or you can just take a measuring tape out and measure it. Anyway, that's the dimensions. And this works, as far as I know, it works at all brands of the rectangular, like 2 meter square solar panels. I haven't got the panels drug over on it. However, this is the panels that it was set up on. And what brand are they? Oh, yeah. I flipped this over for some reason, so I can't read it. It's not Russian. It's the thing is upside down. It's QPLUS, Q plus L-G 4.2335W. So it's 335 watts. It's 35.1 to 40 volts, has 72 cells. Anyway, to put this on there, you just take the whole dang group, move it from the outside corner, say, of this. This is the same perimeter wall, and move it down to that point is on the other one. But right now I'm trying to do some other stuff, so I don't want that over there. Anybody still with me? Probably not. These are the heights of the well, the end of the tube, 1.5 inches by 3. It's showing the mounting bracket stuck on it. Height of the tallest column. Well, it's only 5 feet. I thought it was taller than that. I learn something every day. Middle one is this little under 4 feet. And you'll notice that it looks like it's in the air, and it is. Reason for that is because I just haven't made it any longer. It's the drawing. The dimension up here above this is to the floor like it's supposed to be. So it really is 470647. That came from a conflict right here. This mounting pipe and this clip were in the same place. So I moved it over, and when it moved it over, naturally it slid up this angle, and that picked it off the floor. So that's why that's screwed up. But my dimensions are right. It's just the picture's not so hot. And the other end of the 1.5 inches by 3 is that tall, and the column that goes to the bottom of the mounting plate, the top of the concrete. And this is from the edge of the foundation. The blue is the deeper part, the footer, this part of this purple floor. It's really all monolithic. And the red things, that's yellow from a distance. The red thingamajigs is a 2-foot square piers that the posts are on. They don't stick down much below the footer. And actually what I'm going to do is I'll pour 2 inches of concrete in the holes, and then set the rebar chairs on that, and then pour everything from that. I don't think there's anything else to talk about on this. See if we've zeroed in on everything on the drawing. I've erased all the junk that doesn't make any difference. I'll tell you what, I can zoom this thing to cover everything. Yeah, we've looked at pretty much everything on here. And just as a reminder, here we have well, you can't read it because the dimensions is